And that was the Eagles, Hotel California. Don Hensley, right? And that's pretty, I'd say if there's any song, when you hear the Eagles and you think of them, Hotel California is probably that one song. So our continued effort to go ahead and include groups and legendary performances. How about formulas? Let's see how you can do today. Let's see if we can go 4 for 4. So formulas, we'll just start with that, a little bit of a review again, and then we'll do counting for a review. Now again, what I'm trying to do is keep this in front of you on a daily basis, because at the end, you need to be able to do counting, formulas, everything we do in the Orange Book, you will have in the final at the end. So with that, let's go to some formulas. So the first one, let's see if we can go 4, 4, 4. That sounds awkward. 4, 4, 4. 4 out of 4. Formulas. First one, area. Circle. Okay, write out the formula on paper, please. Make sure you put A equals, not just the right side. Area of a circle. The second one, the perimeter for a rectangle. Remember to put the letter P on the left side of your formula. That's our second one. The third one, let's take the circumference of the circle. That's the third one. Number 4, area, right triangle. Okay, those are my 4. Let's see if we can come up with all of them. 4 different formulas. Give you a moment to finish your writing, and we'll see how we can do here. Okay, for the area of a circle, who has it? Adrian? Okay, so I'm being asked a question. We got it down to 2. It's either pi r squared or 2 pi r. How would I know which one to take? There, I've given you a hint as to how to decide that. Area is usually written in what form in terms of units? What would you say? Square feet, right? But if you had circumference, you would say feet. So given that, which is going to give you square feet? R squared or R? R squared. So that would tell you that it's pi r squared. Okay, so we got that one. If you had a 3, cubic, volume, not area. Now,
is it just pi r squared or pi times?
You could put pi with a little x r squared,
Okay.
but it's usually in algebra written just with the pi r squared together, no x. Perimeter of the rectangle. Tia, do you have it? You're doing volume. Remember, if you have r cubed, you're going to have a volume. Okay, we're talking about perimeter now. So I don't want, and again, it's not a circular. This is just a rectangle, like a two-dimensional box where you have length and width. So I want your perimeter of your rectangle. Okay. I heard something about length. Okay, say that again, please. Passing the buck. 2 times L plus 2 times the width, right? Because you think of going for a walk, you walk on the length, then the width, then the length, and then the width. So 2 L's and 2 W's. Okay, this one was already given away with the previous answer. The circumference is your 2 pi r. Now, the area of your right triangle. It's got a fraction in it. It's half of a rectangle, right? So it's 1/2 the base times the height. Again, you can put x's between. Now, how do you remember that one? Well, you can remember it by drawing a rectangle. So if I think let me just sketch something here briefly. I have a rectangle, and half of a rectangle would be a right triangle. So if you think of this being, instead of length and width, think of this being B and H, you would say the area of that rectangle is BH. But the triangle gives you half of that rectangle, so you get to this formula down here for the area of your right triangle. Anybody with 4 out of 4 this time? 3 out of 4? Okay, some of you are 3 out of 4. That's good. I just want to keep coming back to this because at about a week from this Thursday, we should be thinking in terms of a test on formulas. So this Thursday, I will take time to cover formulas again. We'll spend a whole day on it. And then the following week, we should think about a test on formulas. Yeah, that's my thought. Now, I'm a little bit concerned there in terms of we have a midterm coming up. So keep in mind that what we are doing in the computational review, we're doing lesson 18 today. That's the last lesson. Then we're done with this book, but I have to have checked off all 18 lessons, 1 through 6, 7 through 13, and 14 through 18. So I'm going to have to find some time to do that either when you're taking the midterm, or you can come by the office 1 to 2:30 daily, Monday through Thursday, and I can check it then. But I need to, at some point, check your book before the midterm is over. We are going to spend some time on Monday starting the review for the midterm. And that probably will involve giving you some midterm reviews that you can do at home, bring back, and we can talk about them. By Wednesday, we may be taking the midterm of next week. And that's 1 hour, 30 problems, 2 minutes a problem. Then we would have a test on Thursday on formulas, is my thought, making it a very good week. No, the formulas will not be in the midterm. Nothing in the orange book on the midterm.
Oh, okay. Nothing in the
So just the 18 lessons on the midterm. Okay? So you can relax a little bit. Not much, but a little bit. Okay, lesson 18, if you will, please. That's where we go next. The title of that lesson is Percents. The key to percents. And I'm going to come back and get the book underneath the document cam here. So we're looking at lesson 18, and it is percents. This is the formal title of it. Let's put that up there for a moment, Ernie. Lesson 18 and percents. Now, if I say miles per hour, what does that mean to you? No, stay where you are there. I'm just getting shocked. Miles per hour. It's what? How fast you're going. But how do we write it? What does the MPH mean? What does it mean? MPH. I'm asking. That's what it means. Miles over hours. So if I've been giving the verbal statement, it's miles per hour, MPH. Okay, if I go 500 miles, and I do it in 10 hours, how fast were you going? I divide, reduce, correct? What do you get? I'm dividing by a power of 10. 10 to the first. This is from yesterday. So I'm dividing by 10 to the first. It moves the decimal that you don't see one place to the left. So it's 50 mph, but it means 50 miles over 1 hour. Now, if you are driving 500 miles and you're in hilly country, one-lane road, that may be all you'll average. You get behind a truck or something, it slows down. You can be on the freeway going from here to San Francisco, 7 a.m. in the morning. Sometimes you don't even average this. Sometimes with an accident or something, you may only average what? 20 miles per hour. Okay, so, but understand what it means to have an MPH. Per means over. Okay, so my question, coming back up to here, percent. So if I say that I have 75%, doesn't that, in the same way, suggest to you that you have 75 over something? And cent, century, centennial, 100. So 75% means you have 75 over 100. We typically use a shilling fraction. That means we try to write it so we don't have to, in an old typewriter. God, I talk about typewriters, and I think everybody knows what I'm talking about. If you've been using a word processor with a computer for the last 15 years, there was an archaic instrument called a typewriter, where you actually had to move the carriage down one line at a time, and you tried to keep things in a single line. So this was the fraction that was written, called a shilling fraction. And if you wanted to be lazy and you were doing this script, instead of doing this line and the 2 zeros, you just said, we'll do that. That became your percent sign. But never to leave things so routine and mundane. We thought, well, we can embellish this, right? And make the fancy percent sign that we're all familiar with. That's what a percent means, and that's the heart of this unit. So the question, if I have these three things now, I had a common fraction, I'm going to call that CF, common fraction. And we have decimals, which we called decimal fractions. But remember, a decimal fraction is just your standard operating decimal. And then I'm going to have a percent. Now this unit is about, this review, is about starting with any one of these and going to the other two. So for example, if I start with 75% and I want to write it as a common fraction, we know that 75% means what? 75 over 100, and then I reduce. And the 25 goes into 75/3 into the 104, and I get 3/4. Can we get a decimal fraction pretty easy now out of a percent? And if you think of yesterday and what you did for your homework, if 75 is over 100, 100 is 10 to the second, and I'm dividing by a power of 10, and what does that do? Moves the decimal point to the left 2 places. It's here at the end, and so that forces you into what? 0.75, and I have the decimal. Now you could do this. That is optional and sometimes mandatory if you're in what? In the nursing health areas, because we want to be sure that you know a decimal point's coming. Do you see how I went in between these? Now if you want to go from a percent to the decimal, then all you're going to do, go 2 places to the left, because you divided by a power of 10. Now, the obvious question, how do I do more complicated problems? Okay. So there are some problems that can be a little bit confusing. I'm just going to take a very simple problem. We talked about 75%. Now, I'm going to take a problem that comes out of finance. FHA, Federal Housing Authority, has a mortgage guarantee insurance that they charge if you buy a house on FHA. That is a 1/2 of 1%. 1/2 of a percent. So, Ernie, I still have room over there behind me. So let's go back to that space. 1/2 of a percent. Now, I'd like to be able to write that in two ways, just because, one, I'd like you to be able to do it in two different ways, and furthermore, because sometimes you'll need it at least as a decimal. Now, 1/2 is the same as what decimal? Just 0.5. So I can rewrite this way. Interestingly, and this goes back to the history of banking, banks are much more inclined to use fractions than decimals. So if you hear of an interest rate, it'll be 2.5 or 1.5 or 1 3/4. They hardly ever give you the interest rate as a decimal. But this is not the decimal itself. This is still a percent. So this means what? 0.5 over
10 to the first.
over 10 over 10 to the second. 100 is 10 to the second, right? 0.5 over a percent, over a cent, meaning over 100, which is 10 to the second power, because 100 has 2 zeros in it.
So it's always 100 on
Yes, always 100 on the bottom when I have percent. Now, what am I going to do with the decimal point, since I'm dividing by 10 to the second?
Move it
2 places to the left. And so this is the decimal. Now let's say that you buy a house for $100,000. And by the way, what is the median, the average price of a house in our area, even with the decline?
400 to 500,000.
Well, somewhere between 3 and 500,000. So we might, just for the sake of argument, be very conservative and say 300,000. That would be very conservative. Now, housing prices are dropping. But let's say it was 300,000. Well, what I'd like to know, just for 100,000, how much would you have to pay? You multiply this by 100,000. And what is 100,000 as a power of 10? 10 to the fifth. So that means you would move the decimal 5 places to the right, which means you would pay $500 to the finance. Well, this is the mortgage company which does all the work. This is the amount that you would be paying to the federal government for this mortgage insurance. That's a 100,000. Now, what about that 300,000? 3 times as much, $1,500. 400,000, $2,000. You're going to write out a check, and it doesn't do anything to you other than guarantee that if you default on your mortgage, it's been covered to the federal government. Sort of like an insurance policy. Well, let's come back to this problem now. I have 1/2%. I want it as a common fraction. Again, remember, this is meaning 1/2 over 100 over 1. Okay, Ernie, I'm going to get an eraser for a moment. Just stay where you are. That didn't read as nicely on the screen as I'd like, so let me clean it up and make that 100 a little bit more readable. What kind of fraction do we call that? 1/2 over 100? We had a name for it. Okay, uncommon. That's not bad, but it's complex. a complex fraction. How do we simplify that?
0.5 over 10 to the third.
I've got a fraction over a fraction. Complex fraction. Invert, otherwise treat it as a division. This is the same as 1/2 divided by 100 over 1. And then what am I going to do? Flip the 100 over, 1 over 100. So what's my final answer? 1 over 200. So you invert and multiply. And I ran out of room, so I just did that inverting in my head and showed you the answer. Let me walk off camera so you can just look at that for a moment. Now, that was changing from a common fraction to, a percent to a common fraction. Now, I'm going to give you a variety of problems, just so you know what I'm asking you to do on page 181. Let's look at that, so you can see the kinds of things that we're going to do. On 181, as we go to the document cam, we start with a common fraction, and I want it as a what? A decimal. So let's leave that there for a moment, and Ernie, camera 2, if you would, over to the side, and while you're doing that, I'll take a sip of coffee. And we'll see what we can do. So we've looked at how to go from a percent to a common fraction. Now in this case, in the first problem, we're going to look at something like 3/4. It is a common fraction, and I want it as a decimal. I can divide, correct? I could say 4 into 3, or I could just have that memorized. But long division will do it. Now there are a few of these I would encourage that you remember, and let me talk about how I do that. This is a list that can help you. I'm going to write 1/2 in this way. 0.500. Then 1/4 is just 1/2 of a half, isn't it? Okay, well just stay with me for a moment here. I have 1/2 is 0.500. 1/4 is half of what I had here. Well, so what is half of 500? 250. Now if I have 3 of these, that's 0.750. Again, if I know what 1/4 is, 3/4 is just 3 times as much. And so I can multiply instead of dividing. But let's play the game a little bit further. For those of you who end up measuring things for any kind of projects around the house, if 1/8 is half of 1/4, what's half of 250? 125, yes? 125 is half of 250, and you didn't do any division. So if I know 1/8 is 0.125, do I immediately know 3/8 without dividing? It's 3 times this. So what's 3 times 125? 375, correct? So you can use some shortcuts. And just to go a step further, I could throw another 0 here, because I can put more zeros. 1/16 of an inch. What's half of 1250? 0.625. And you can just carry that process very nicely, making conversions. 1/32, keep going, same idea, and you get those very nicely. No long division necessary. Now we do know that there's certain fractions, like 1/3, that do what? They never end, they repeat, correct? And this one is one that you already have done. It's 0.33. Now how do I indicate the 3's repeat? Let's just come over to here. Okay. A line over that, what's another way? Okay, or, now the question, how many 3's before you put the dots? And I like about 3 repetitions before I put my dots, and that means the 3's forever. Or One more. One more way of doing it. Let's see what happens here. This is your long division. We'll carry it through here for a moment. So 3 did not go into the 1. It goes into the 10. Agreed? We got our 9. We bring down the 0. We get a 3 again. We get a 9. Now, obviously, they're repeating, but don't I have a remainder right now?
1.
What can I do with the remainder?
1/3.
Say 0.33 and my remainder, which is 1/3. Now, that is as a decimal.
So that's what you want.
That's what 1/3, those are options. This is probably the one most useful to us, okay? Because as a percent, well, first, let's read that out loud. It's 33 1/3 what? Hundredths. And that means percent. So this is just 33 1/3%. So my point is, if you know what 1/3 is, could you get 2/3 quickly for me? If the 1/3 is 3's forever, the 2/3 is 6's forever. And again, I oftentimes write 3 repetitions before I put the bar, or 0.666 ... or what? 66 2/3. It would be 4/6, which is 2/3, with your decimal point there in the front. Now, this illustrates 2 things that happen with common fractions, and I'm going to mess with this just a little bit, because with calculators you need to realize life is not always this cut and dried. These are terminating decimals. They stop. These are called terminating. These are called repeating. Agreed? They repeat. And when you start with a common fraction and you go to a decimal, you're going to get one of those 2. I'm going to give you another group of fractions just to look at for a moment, so you realize what's happening here. This is something over 9. We know 3/9, correct? That's 1/3. And it's 3's forever, agreed? So we get 3's forever. We know 6/9 because that is 2/3, correct? And we know that's 6's forever. Now, what does it look like if you were to make a conjecture? If there's a 9 in the bottom, what's going to happen? The numerator is going to repeat, correct? So that says that if I had 4/9, I would expect to see nothing but 4's. 5/9, nothing but 5's. 2/9, nothing but 2's. 1/9, nothing but 1's, right? So if I kick this down, 7/9 is nothing but what? 7's. 8/9 is nothing but 8's. What's 9/9? It equals, but it also equals 9's forever. Okay. Now that brings up a question. Okay, Ernie, I'm going to have you pan over a little bit here to the 1/4. 0.25. Now that was a terminating decimal, right? Could I write that as a repeating decimal? And the answer is yes. Back where we were, Ernie. 1/4 could be written as 0.25, but it also can be written as, watch this. That's the same as 0.25. If you have 0.24 with 9's repeating forever, it's telling you that you really have 0.25. So if on a calculator I see 0.2499999 until the end of the screen? Well, it just tells me that I had 0.25. Now that has something to do with this problem in a calculator. Let's say, and I'm just going to use this as an illustration, and nothing's priced at $60. You go to a store, I would really challenge you to find anything at $60. What will you probably see it priced at? $59.99, agreed. Or $59.95, that makes it under $60. You go for gasoline, it's 2.99 9/10. It's under $3. And you feel good. Well, you know the 9/10, but it's under 3. $59.99, it's under 60, and your head sees the $50. I bought it for $50. Well, $59.99. Now, let's say that you have a sale, a discount, and you get a discount of 33 1/3% off. Well, technically, $20 is your savings. However, no, not quite. Here's what you would have in the calculator. And then at some point you run out of room. And my guess is this might be your answer. Which is telling you $20. It's the best it can do. So you wouldn't want to do the problem this way. 33 1/3% is the same as what common fraction? 1/3. Cancel, and you have a fraction and an exact answer. There are times it pays to take a percent and write it as a common fraction. So that brings us then to a different category. Remember the last category was I took a common fraction and I went to a decimal fraction. But there are times that I start with a percent and want to go to what? A common fraction. Or I start with a decimal fraction and I want to go to a common fraction. Now, these that you memorize are pretty nice. So let's slide back over for a moment, Ernie, to this list that I had right here. If you know you have 0.25, you know it's a fourth. You know if you have 0.125, it's an eighth. If you just have them memorized, that's all you have to do. But what happens if you don't have them memorized? So let's come back over to this. Let's say I gave you this as a decimal. Now you say, wait a minute, people don't write decimals that way. Yes, they do. Every time you fill up with gas, it's 2.99 9/10, or 2.89 9/10. So we do that. Banks are very notorious for everything with interest as a fraction. 1 2/3, 1 3/4, 2.5%. But this is just a decimal. How can I write that as a common fraction? Now, I understand that you do have this option. Let's start with that one, just as an option for a moment. How would you read that out loud? Verbal notation. Let's see if you got it. Verbal notation, 0.275.
That's usually how everybody ends up saying it's 0.275.
Verbal notation, not the way I want it. 0.275, you don't want the decimal point if you're going to do what you're doing. You're on the right track. 275 thousandths. Listen to what you said. 275 thousandths. And then just reduce. there's an advantage up here, 0.27 and a half. How would you read that one? Not 275, but what? 27 and a half, what? Hundredths. They're equivalent, but nonetheless look a little bit different. Okay, now what? See, the 7 and a half go together. So that's 7 and a half hundredths. So you had 27 and a half hundredths. What can I do with this? This is, again, what kind of fraction? What did we call it? Complex fraction. It's that on the right side of the front board that we had. Ernie, could you bring that in where we had complex fractions? Well, that's interesting. You threw a switch and I saw a flash. Okay. I hope that's not the demise of a switch. Okay. This is the complex fraction we talked about before. Far right, where it says complex. We have 1/2 over 100. Remember what we did there? We treated it as a division problem. Okay, back to here. What do I have to do before I can do the division? And let's bring it in a little bit tighter, just to this much here, Ernie, if you can. Okay, but, okay, I agree. I want to change the 27 and a half, and what do I want to write it as? No. It is now a mixed number. I want it still as a fraction. What are my choices? Improper. Very good. So what is 27 and 1/2 as an improper fraction? I haven't heard the right number yet. I've heard some efforts, and you're on the right track. 2 times 27. 54 plus 1. 55 over 2, correct? I didn't hear that. If somebody said it, if so, I apologize. Now what am I going to do? Back to camera 1. I'm going to invert and multiply, so I'm going to take this, and I'm going to rewrite it, and I'll go up to here. 55 over 2 divided by 100 over 1. I'm making this much longer than you typically do it. Invert and multiply. Now what? No. That is the correct answer, but I can cancel, can't I? So 5 goes into here. 11. 5 into 100. 4 into 100 is 25. 5 into 100 is 20. And that's 11 over 40. You got it. You have to be able to do that. Okay? Now, what if you ask for this as a percent? As a percent, that means that I want it over 100. So if you read this out loud, you get what? Exactly what we did here, where we said 27 and a half over, you said 27 and a half hundredths. So 27 and a half hundredths. But that is the same as? No. Remember what I wanted it as? I had it. Percent means over 100. Okay. If I start, let's slide over. If I start with a common fraction, I want you to be able to do what? Give me a decimal fraction. If I start with a percent, I want you to be able to give me a common fraction. Let me write this table in a little more complete way. So we'll slide back. If I start with a common, then you have to be able to give me what? Both. A percent and a decimal, which I'm calling DF for decimal fraction. If I start with a decimal fraction, I expect you to be able to revert back to the common fraction or convert it to a percent. If I start with a percent, I want you to be able to give it to me as a common fraction or as a decimal fraction. So I'll just walk off camera, bring that in tight just for that top part there, please, Ernie. So I'm asking you to go from one to two others. So let's come back to page 181 as I go to the document cam. In the second problem, I'm saying start with these decimals and give me a common fraction. Then the third one, I'm just going to scroll up here. So I scroll, and let's see if I can try to get that a little bit cleaner. I start with the decimals, and I'm doing what in number 3? What does it say? I'm on page 181. Go to a percent. Okay, let's stop there for a moment. If I'm at a decimal, how do I get the percent? I have a decimal. How do I get a percent? What's the rule we can use? There are two rules that we can talk about here. I start with a decimal, and I want to go to a percent. Okay, let's come back to the book for a moment, Ernie. I'm starting with the decimal. I want to go to the percent. Let's look at this problem we did right here for a moment. I was at a decimal, and I wrote the decimal to what? The hundredths position. And that said 27.5 hundredths, so that gave me 27.5%. A reminder, let's see if I have it written in any, without a common fraction involved, and I don't see one. If I had, and I think this is just one you know, if I have 75%, as a decimal, it's 0.75, correct? And so we just say that's 75%. What have I done in each case as I look at where the decimal point was and where it is as a percent? It started here, and I moved 2 places to the right. So to go to a percent, I went to the right. I was here as a decimal, but I wanted to go to the what? Go to the percent, and I moved it 2 places to the right. Now let's compare that. I'm trying to see a problem that I did a moment ago where I had something over 100. So let's say, just as an illustration, that I have 85%, but that means the same as what? 85 over 100, which is 10 to the second. And what happens when I divide by a power of 10? Move the decimal to the left 2 places. So that becomes 0.85. So the argument, if I start here and want to go to the decimal, do you hear the L in what you're going to? You move your decimal to the left. If I start this place and I want to go to the percent, you hear the R and you go to the right. And that may help you remember. So if I start with the percent and go to the decimal, I will move to the left. If I start with the decimal and go to the percent, just move to the right. The percent to a common fraction, write something over 100 and reduce. How did we get from the decimal fraction to the common fraction? Let's bring that up a little bit higher so I can get, okay, a little bit higher, there. How did I go from the decimal fraction to the common fraction? I can just talk to myself, although there's another alternative and I'm running out of space. Let me leave that there. I'm going to use the document cam to do this and illustrate it that way. If I want to go to a common fraction from a decimal, let me show you a technique that relates to what we did yesterday. Okay, what I'm going to do, Ernie, is come to this problem. Now this is a decimal. And I want it as a common fraction. Now the decimal you don't usually think of writing over 1. And as a fraction, I don't like a decimal in the top. How can I move that decimal in the top, get it to the end so I can throw it out? Multiply by what now?
10 to the
10 to the third. I want to move this decimal 3 places over. So I'm going to multiply by 10 to the third. And what must I do by the basic principle of fractions? The same thing here. What does this exponent do to that decimal? Moves it to the right. So that's 375. What happens in the denominator? I have my thousand. So let's come off there for a moment. That then is just going to become 375 over 1,000. And this technique always works. What can I then do? Reduce. That reduces to what? Actually goes to 3/8. If you take 125 into the numerator, you get a 3. 125 into the denominator, you get an 8. You may instead look at it in terms of dividing top and bottom by 5 and doing it again and doing it again. And you'll eventually get to 3/8. But that technique works. So back with camera 2 and the side board. What is our technique for going from a decimal fraction to a common fraction? I have 2 ways of doing it. One was reading it out loud. Okay? So to that extent, if I come back to this one and read it out loud, I got to here. Okay? And that would eventually get me to what? I can reduce that, get that over 100 as we did over here, and get to 11/40. That's what I did there. Okay, let's go up to the top one. Common fraction. How did I go to the decimal? Long division. Or you have what? Certain fractions memorized. If I give you 3/4, you know it's 0.75. What about a common fraction to a percent? What are your choices? Go to the decimal first, then go to the percent. But I'm again going to leave that and go back to my piece of paper because I have one alternative here I want you to know about. It's not something you're necessarily going to do. But let's say I'm going to come up with a common fraction. Okay, my common fraction is this. I want it as a percent. What does percent mean? No, but what does it mean? Percent. Over 100. Could I rewrite this as something over 100? 5 goes into there 20, correct? So I, in essence, multiplied the 5 times the 20, and then do what? Do the same thing up here. There's my 60 over 100, but that means I wanted what? 60%. Percent, and 60 over 100 is 60%. Now that's a neat little technique. Let's leave it there for a moment so you can look at it. Now that doesn't always work as well as I'd like, because if I had 3/8, 8 won't go evenly into 100, but it will go into 1,000. Nonetheless, if you can do this technique that I have on the screen, it's a nice one to use. Now your homework is in 2 parts. 1, 30 problems you're going to do on page 181. 30 of them. Otherwise, there's 6 problems, 5 parts each, so that's 30. And then you get to go to the last review test for this book. And that's an 18. And I have, as we look at the document cam, very similar problems, a decimal to a percent, then a common fraction. Otherwise, you start with the percent, go to a common fraction. You start with the percent, go to a decimal. You start with a percent, go to a decimal, and then using shortcuts to move the decimal around. Well, Ernie, we've managed to get through in another hour, so feel like Tom and Ray managed to do that with Car Talk. Not quite the same.